Good morning, students. Now we are going to discuss about the fourth colligative properties, that is osmotic pressure. So here first we have to know the phenomenon osmosis. So what is osmosis? So you see here the phenomenon of the flow of solvent through a semi-permeable membrane from pure solvent to the solution is called osmosis, or that is the flow of solvent from low concentrated solution to higher concentrated solution through a semi-permeable membrane, that is called as the osmosis. So here osmosis means that is the flow of solvent through a semi-permeable membrane from solvent side to the solution side, or from low concentrated solution to that of the higher concentrated solution. Then we will see what is the osmotic pressure. So the pressure applied on the solution side to just stop the passage or flow of solvent into the solution through a semi-permeable membrane, that is called osmotic pressure. That means this is the minimum pressure which just stop the flow of solvent from solvent side to that of the solution side through a semi-permeable membrane, that is called osmotic pressure. Now another term we have to know here, that is reverse osmosis. Reverse osmosis means that is just opposite to that of the phenomenon of osmosis. That means here it will be the flow of solvent from solution to that of the solvent side. So when it will flow, so definitely we have to apply some pressure on the solution side, then only the solvent will flow from solution to that of the solvent side. So you see here the phenomenon of the flow of solvent through a semi-permeable membrane from solution to pure solvent is called reverse osmosis. This process occurs when the pressure applied on the solution is more than the osmotic pressure. So reverse osmosis is used for the purification or desalination of water. So next, another term you have to know, the semi-permeable membrane, SPM, semi-permeable membrane. So the membrane which allows only the solvent and not the solute to pass through it. So in a osmosis, in the phenomenon of osmosis, a semi-permeable membrane is needed which allow only the solvent to pass through it, but it will not allow solute to pass through it. So example, parchment paper, cellophane membrane, etc. So now osmotic pressure, it is a colligative property. That means it depends on the number of the solute particles. So that means definitely this osmotic pressure has a relation with the number of solute particle present in the solution. So that means there is one relation, and we have to know here that mathematical relation. So you see that for dilute solution, it has been found experimentally that osmotic pressure is proportional to the molarity C of the solution at a given temperature capital T. Capital T means temperature measured in Kelvin scale. That means osmotic pressure that is proportional to the molar concentration of the solution at a given temperature T. So that means this osmotic pressure pi, that will be equal to now CRT, where R is a gas constant. So this expression we have to remember, that osmotic pressure pi is equal to CRT. Here C is the molar concentration, that means mole per liter. R is a gas constant, and T, capital T, that is a temperature measured in the Kelvin scale. So here these are the term pi, C, R, T, osmotic pressure, molar, like that. But now you see that concentration, that is a molar concentration. So concentration, that is number of moles divided by volume of the solution in liter. So C is equal to N by V. N is the number of moles of solute dissolved in V liter of the solution. So instead of C, we can put the value N by V. So then the relation will be pi is equal to, instead of C, N by V into RT. That is one equation. Again, N, that is the number of moles, that is given mass divided by the molar mass of the solvent. So that means WB by MB. Here WB is the mass of solute and MB is the molar mass of solute. So now substituting the value of N in the equation 1, will get pi is equal to, now instead of n, that is wb by mb into RT divided by V. So this is the expression regarding the osmotic pressure, we must remember. Or by rearranging that molar mass, that will be equal to this WB into R into T divided by pi V. So thus using the above equation, molar mass of the solute is calculated. That means this is the equation to calculate the molar mass. So here whatever the colligative properties, 4 colligative properties we have discussed, their main motto is to find out the molar mass, you remember. So in each case we are getting one expression, mathematical expression to find out the molar mass. Out of this, there are some advantages regarding that of the osmotic pressure. So what are these? That osmotic pressure method has the advantage over other methods, as pressure measurement is around the room temperature and the molarity of the solution is used instead of molality. So you see, in other cases, whatever the elevation of boiling point or the depression of freezing point, in that case we have used the molal concentration, but here we are using the molar concentration. So that is mole per liter. So that is one way, convenient for calculation. Then another, that whatever the pressure that can be measured at around room temperature. And another advantage is that this is useful for the biomolecules, as they are generally not stable at higher temperature. Say in case of the elevation of boiling point, in that case we have to boil it, we have to we have to boil it. So but if we use the osmosis, phenomenon osmosis, then what happens, that we can measure at room temperature, and biomolecules are not stable at the higher temperature, and biomolecules means the polymers, they have also pore solubility. So this way osmosis or osmotic pressure is little bit osmotic pressure has little bit advantage than the other method for calculation of the molar mass. So these are the 4 colligative properties. The expression for all the 4 colligative properties you must remember, and in the following class we will do the numericals. So this is for today. Thank you.